Hello and welcome to 9.1 Radical Expressions. You are going to be getting these notes, if you have not gotten them already, from the sub today. And we're going to go through and treat this as if it's a normal class period. So make sure you have a calculator on your desk and a pen or pencil to write with so you can take notes. You can pause the video now if that's not the case. I'm going to move on. Today's learning objectives is simplifying radical expressions. And a radical expression is an expression that contains a radical. A radical is something like a square root symbol. The radicand is the number underneath the radical. So if I have, let's say, square root of 2, the 2 is the radicand. Okay. The key concepts that we're going to look at here, we're going to look at how to simplify square root expressions. So we are going to take a square root and we're going to put it in simplest form. We're going to know it's in simplest form when the radicand, or the number underneath the radical, has no perfect square factors other than 1. The radicand has no fractions, and there are no square roots in any denominator. So now at this point, I would like perhaps the sub to pause this video and pass out the square root list. That's very important for you to have right now. All right, so now at this point, we're going to simplify the the expressions that they gave us. Example 1, we have the square root of 2 divided by 72. So one of the major rules is that the radicand, so 2 over 72, has no perfect square factors other than 1. The other rule is that there can be no square roots in the denominator. So I'm going to show you how this actually becomes a square root in the denominator. So you can break this up into square root of 2 over square root of 72. Now, the square root of 72 is not a perfect square if we look on our list. I'm just going to show you the list right here off to the side. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. I'm just going to stop here for a minute because you get the point. And I'm going to note that 72 falls between 8 squared and 9 squared. So it is not quite a perfect square number. So we know for sure that 72 is not perfect. However, 72 could be composite. So what does composite mean? Well, 72 could be made up of one of these numbers on this perfect square list times something else. So it's not prime. So composite is the opposite of prime. So if we're going to take a look, we have to look for the largest number on the perfect square list on this side down here, this 1, 4, 9, 16, that would be divisible into and evenly into 72. That's going to come in handy really quickly. So just want to make sure that you know what we're looking for in order to simplify. The other thing that we're going to need to know how to do is something called rationalizing the denominator. So for step 3, where it says no square roots in any denominator, we're going to be rationalizing the denominator. Okay, so rationalizing the denominator is going to make sure that there are no square roots in this denominator. So let's take a look here. In order to rationalize this denominator, what you're going to do is you're going to take that radical in the denominator and you're going to create a ratio of 1 by multiplying this whole thing on the top and the bottom. So once I do that, I multiply across the top, I get square root 2 times square root of 72 over, now square root of 72 times square root of 72. Well, 72 times 72 if you wanted to do this, is a fairly large number. It's 5,184. If you don't want to take the square root of that number, I mean, you could if you wanted to. If you don't want to take that square root of 5,184, which actually happens to be 72, you should know that anytime you have a square root times a square root and they have the exact same number, it's just going to be that radicand without the square root. On the top, we could also multiply these. It's not going to really give us really what we need. So what I'm going to do is I'm going to leave the square root of 2 because this is not on our list and it's the only number it's divisible by is 1, because 2 is the only even prime number. And 72 is definitely divisible by one of those numbers on this list. So 72, when we look at it, is divisible evenly by 36. So 72 can turn into, let's see, 36 times square root of 2. All right, so at this point, I'm going to look at this answer that we have here, and I'm going to have square root of 2, which is prime, and it's not a perfect square. This square root of 2 is prime, which is not a perfect square. I'm going to combine that to make that square root of 4, because 2 times 2 is 4. And I also am going to put square root of 36 next to it. Whoopsies. 36 over 72. So now, I'm going to keep working over here. Sorry, I'm kind of going in a loop this way. Square root of 4, look on this list. The square root of 4 is 2. Times the square root of 36 is 6 over 72. What is 2 times 6? Well, that is 12 over 72. And if we're going to simplify this, let's see, how many times is 12 going into 72? I'm going to say that's 6 times. So we know we can divide top and bottom by 12, and I'm going to get 1/6, and that is my final answer. So we did a lot here. First and foremost, we rationalized the denominator by multiplying the top and the bottom by root 72. Then I combined by multiplication 72 times 72 into 5,184, and on the top I multiplied 2 times 72. I realized that 2 is prime, so I didn't touch that. The square root of 2, I should say. The square root of 72 is composite of one of the perfect squares, 36, times 2. 36 times 2 is 72. The square root of 36 is 6. Square root of 2 times square root of 2 is square root of 4. And then 2 times 6 is 12, and we simplify it that way. All right. So next, we're on to the good stuff here. So in this case, I have a radical, and underneath my radical, I have a radicand that's being added. So I have 9 plus 16. 9 plus 16, I can't separate these because there's an addition sign in between, is 25. And it just so happens that 25 is on our perfect square list. The square root of 25 is 5. Actually, if you want to be more specific, it's plus or minus 5. Okay. So here's the you try. You can pause the video now while you try. And I want you to see if you can do these problems. So here we're back. We're looking at these particular problems right here. The square root of 256 divided by 4 looks like the square root of 256 over 4. And you might be tempted to rationalize the denominator here, but square root of 4 is actually a non-radical. There's no root to that because the square root of 4 is a perfect square. It's 2. And the square root of 256 is 16. So 16 over 2 is 8, and that's your final answer. Square root of 40 plus 9 is a square root of 49, and we all know the square root of 49 is perfect, hopefully, and you should get plus or minus 7. And lastly, we have the square root of 25 plus 144. 25 plus 144, we're trying to figure out if that's going to be a perfect square. And that happens to be 169. And the square root of 169 happens to be another perfect square, which I don't have on this list right now. So we'll do 11 squared, 12 squared, 13 squared, and 13 squared is 169. So the answer here is plus or minus 13. There you go. All right, let's flip the page. And we're going to talk about the product property of square roots. And we kind of just went over a little bit of this, but again, I'm going to reiterate it. For any non-negative real numbers, a and b, the square root of a times b is equal to the square root of square root of a time. Square root of a times the square root of b. Square root of a times the square root of b. Hello. So that's funny to read. All right. So if you have a square root that looks like this, what they're saying, it's the same thing as square root of a times the square root of b. So if I have the square root of 4 times 25, I can multiply that together and get 100, which is 10. Or I can separate them and say square root of 4 times the square root of 25. The square root of 4 is 2. The square root of 25 is 5. 2 times 5 is 10. So you could do either one of those. And further, what we just kind of talked about here, if you have a times b or two numbers being multiplied, you can separate them, but a and b both have to be positive. They cannot be negative. That's the kicker here. It's non-negative numbers. Okay. So simplify. Here's some examples. It says simplify, all variables represent non-negative numbers. Fantastic. So 18. Square root of 18. I hope, that this is a composite number. We know that 18 is not a perfect square by looking at your list, but it is definitely divisible by a perfect square. So one of the perfect squares that is a factor of 18 is 9. So we know that 18 is 9 times 2. And the square root of 9 times the square root of 2 is going to give us our final answer. The square root of 9 is 3. The square root of 2 is the square root of 2. And this is our final answer. Okay, so in order to do this, a square root is basically, has a number 2 there. Other roots, the third root would have a 3. The fourth root would have a 4. For some reason, for square roots, they don't put the 2, they just leave it like that. So if you see a root without a number, that's always a square root. In order to represent variables, what you're going to do is you're going to match or group up the variable letters into the groups that match the roots. So for this problem, oopsies up here, I have 1, 2, 3, 4 x's and 3 y's. Because we have a square root that's groups of 2, I'm going to group them. Let's see, 1, 2. So I can make 2 groups of 2. So underneath here, my radical, I'm going to have x squared times x squared. And for my y's, I can only make one group of 2. So I'm going to have y squared. The other leftover y, or anything that's left over, has to go on its own radical. So these are like the perfect square radicals, and this is kind of like the prime radical. So a square root is the opposite or reciprocal function from a square power. So the root and the power cancels. The root and this power cancels. The root and this power cancels. So I'm left with x times y times root y. And to make this even better, it's going to be x squared y times root y. I'll do another one kind of similar. All right, the square root of 27. 27 is not a perfect square, but it is composite. And it's composite by a perfect square being 9 and 3. I know this is a square root, so x squared is my one group, and I'm just going to leave it like that, and y is another. So let's move out our ones that are perfect squares, which is 9 and x squared. And then we're going to take the other one, that the prime set, prime factor, move it over here. So the 3 and the y. The square root of 9 is 3. The square root of x squared is x. And I'm going to leave it just like that. Okay, so now for you try, we're going to pause the video at this time. So for 128, we really have to think about what numbers can go into 128. And you want the highest number, or the highest perfect square number that will divide into 128. So what I would do if I were you is I would say 128 divided by 4 and see if that fits. And you know it's going to be 32, 4 and 32. You can actually write those off to the side, but you want to kind of make sure you can get a higher number. So if 4 goes in there, maybe 16 will. So if you do 128 divided by 16, it's 8. So let's see. So 16 times 8 is 128. And notice this side of the column that I'm making my factors, these are the perfect squares. These sides are the composite. Can we go any higher? So the next one would be 36 maybe. So 128 divided by 36. And that does not work out. That is not perfect. So let's see, can we go any higher? 128 divided by 64. And I got another one. So I want the highest number that is going to give the highest perfect square that's going to be a factor of 128, and that is 64. So 64, square root of 64 times the square root of 2. So I have actually 8 times root 2. Over here, since this is a square root and I have 3 x's, x, 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 and 2 y's, I can bring out 2 x's. So you're making groups of 2. So in my my perfect square factor, it's going to be x squared and then y squared. But I still have this 1x left over, so that's going to be multiplied by something else. The root and the square cancel, so it's just going to be x, y times root x. Okay. The last one here, it's the square root of 48a squared b. Now 48, you have to tell if it's divisible. So you're going to go 1, 4, 9, 16, 36, and then the next one would be 49, but 49 we can't do because it's too high. Which one of these numbers is 48 divisible by? So is 48 divisible by 36? What do you think? I would say no, right? Is 48 divisible by 16? And it is. So 16 times 3. And then you know that you're going to make groups of 2. So I actually have 2 A's, so I can put that over here. But I have 1 B, so I have to put that over here. The square root of 16 is 4. The square root of a squared is a. And it looks just like that. You can stop the video now and take any questions or rewatch any part you would like before we move on to the next section. Thank you.